Good evening everyone, good evening. Good evening, there were some technical issues, I'm really sorry, so you had to wait for like 10 to 12 minutes, right? So there were some technical issues going on, I was not able to start the session, but I hope it's fine now. You can just let me know in the chats if I'm audible and visible to everyone. You can just give me some green signal from the chats so that I'll get to know that if I'm audible and visible to every single guy, yeah? Is that? Can you let me know in the chats, my dear people? Right? Perfect, okay, thank God. All right, just give me a second, we'll be starting, yeah? Just give me a second. Okay, so people, as you all must be knowing, tonight it's going to be our second session from the chapter mole concept, right? In the last session of the mole concept, we talked about some basic terminologies and what were those terminologies all about. We talked about something called as atomic mass, molecular mass, molar mass, right? We talked about the average atomic mass of the isotopic mixture, right? I gave you certain basic results by means of which we can calculate number of moles of a particular substance, right? Those were the small things which we discussed in the last session. And what all things we are going to cover in the tonight's session? We will be talking about the mole concept, right? We will be talking about the average molar mass of the gaseous mixture, and then we'll be starting the stoichiometry as well, okay? So before starting the session, the ones who have just joined in, who are new to the channel, let me introduce myself. Well people, my name is Wassim Sir and I'm your chemistry master teacher right here on this NEET Elite channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this NEET Elite channel, yeah? So do like the video, share the video with your friends, and do subscribe to the channel as well, okay? Perfect. So people, you can let me know in the chats if you people are super duper excited for the tonight's session as well, yeah? Let me know fast in the chats. Let me know fast in the chats if you all are super duper excited about the tonight's session as well. Right? Let me see the josh of the session again, then we'll be starting. Perfect, guys. Perfect. Perfect. Wonderful, guys. So let's get going. Let's get started with the things which we are going to cover in the tonight's session, right? I want you guys to take a note of every single thing which I'll be mentioning on the screen, right? Okay. So first, I'll show you exactly the calculation. We will be talking about something called as calculation of atoms, electrons, protons, neutrons, and ions. This is one more small topic which we are going to cover over here in the tonight's session. That is the calculation of atoms, electrons, protons, neutrons, and ions. How do we calculate the atoms? How do we calculate the electrons? How do we calculate the protons? How do we calculate the neutrons? And how do we calculate the ions, right? Let's have a look exactly how do we do that, okay? Before talking about the question, let me just give you one small block diagram, right? You guys are just going to remember that block diagram, and if you remember that block diagram, you can easily solve the equations which are based on the calculation of atoms, electrons, protons, neutrons, and ions, okay? Now have a look what I'm going to talk about. See guys, I'm writing over here a term called as given quantity. Whatever will be given in the question, which can be mass of the substance, which can be volume of the substance, whatever will be given as per the question, that is something I'll be calling as the given quantity, right? Whatever will be given in the question, that's something I'll be calling as given quantity. My first step always is going to convert the given quantity into number of moles, right? My first step always is going to convert the given quantity into number of moles, yeah? This given quantity, it can be in terms of mass, it can be in terms of volume, etc. And we have already discussed how to convert mass of the substance into moles. We have discussed how to convert volume of the gas at STP into moles, right? So whatever will be given in the question, that's something I'll be calling as a given quantity. My first step always is going to convert the given quantity into number of moles, right? Once you get the number of moles, from number of moles you can easily calculate the number of molecules. And in the last session we have discussed like how to convert number of moles into number of molecules. It is simple. You just need to multiply the number of moles by the Avogadro's number. You will be getting the number of molecules. As simple as that, right? You'll be simply multiplying number of moles with Avogadro's number. You'll be getting the number of molecules. And once you are done with the calculation of molecules, from molecules easily you can calculate the atoms, you can calculate the electrons, you can calculate the protons, you can calculate neutrons, ions, whatever you are supposed to calculate among these quantities, you can calculate them by just remembering this block diagram. That's all, right? Once more I'm telling you, convert the given quantity into number of moles into molecules, right? And from molecules, you can calculate anything, whatever will be asked as per the question, okay? Let me give you one small question over here, by means of which you'll understand how to use this block diagram, yeah? A small question I'm giving to you, right? Or before giving the small question to you, let me tell you one more basic thing first. Right? Let's say I have got an atom X. Let's assume I have got the atom X, right? This is an atom of an element X. Its atomic number is Z, its atomic mass is M, right? And this atom, it does not have any charge on it. It is electrically neutral. I'm assuming this atom to be electrically neutral, okay? Remember, whatever will be the atomic number of this element, same is going to be the number of electrons present in one atom of this element. And same will be the number of protons present in one atom of this element, right? If this atom is going to be electrically neutral, if there was no charge on the atom, whatever is going to be the atomic number of the atom, same number of electrons and same number of protons will be there in one atom of this element. This is something basics which you all would have studied in the earlier class as well, okay? For example, if I talk about nitrogen, what is the atomic number of nitrogen? It's 7. What is the atomic mass of nitrogen? It's 14. Nitrogen is not having any sort of charge right here. Now, if I need to calculate how many electrons are there in one atom of nitrogen, you will say one atom of nitrogen contains 7 electrons, one atom of nitrogen contains 7 protons as well. What about the neutrons? Neutrons you calculate by the formula atomic mass minus atomic number. M minus Z, it gives me the number of neutrons. So if I'll ask you how many neutrons are there in one atom of nitrogen, you'll say 14 minus 7, that comes out to be 7. So there are 7 neutrons in one atom of nitrogen. As simple as that, right? Let's say I'm writing Na positive. Since there is a positive charge on this sodium, right? Okay. Now have a look. If I ask you what is the atomic number of sodium, you all must be knowing it's 11. If I ask you what is the mass number, what is the atomic mass of this sodium, you'll say 23 mu, right? Atomic number 11, mass number 23, okay? Now, if I ask you how many electrons will be there in one Na positive, you'll say the number of electrons in one Na positive will be 11. Since there is a positive charge, since there is 1 unit of positive charge, that means this sodium, it has lost 1 electron. So 11 minus 1 comes out to be 10, right? By the presence of positive or negative charge, nothing happens to the number of protons. By the presence of positive or negative charge, nothing happens to the protons. I'll say there will be exactly 11 protons in Na positive. If I ask you how many neutrons are there, you'll say 23 minus 11. So neutrons are going to be 23 minus 11, that means 12, right? Similarly, if I write something like this, these are all basics, right? Let's say I'm writing something like this, N tri-negative. I'm writing N tri-negative. Now there is a tri-negative charge on this atom. That means this atom, it has gained some 3 electrons. This atom has gained some 3 electrons, right? If I ask you what is the atomic number of nitrogen, you'll say 7. If I ask you what is the mass number of this nitrogen, you'll say 14, right? So in one N tri-negative, how many electrons will be there? You will say 7, and since it has tri-negative, that means it has gained 3 electrons, so 7 plus 3 comes out to be 10, right? By the presence of the negative or positive charge, nothing happens to the number of protons. So protons will be again the same, that is 7. And if I ask you what about the neutrons, you will say mass number minus atomic number. 14 minus 7, it comes out to be 7 only. I'm sure it is clear to everyone. This is complete basics, right? Okay. Now have a look exactly how do we do the calculation of electrons, protons and neutrons. Have a look exactly what I'm going to talk about, yeah? For example, I'm writing a simple question over here. The question is, let's say I'm writing calculate the number of atoms, electrons, protons and neutrons in 67.2 liters of carbon dioxide gas at STP. Let's assume this is the question. I need to solve this. A very simple and basic question, right? What do I need to do? I need to calculate the number of atoms, electrons, protons, neutrons in 67.2 liters of carbon dioxide gas at STP. Now have a look how it's to be solved. Simple question, have a look. First of all, what do I need to calculate? I need to calculate atoms, I need to calculate electrons, protons, I need to calculate neutrons, right? And in order to calculate atoms, electrons, protons, neutrons, ions, I need to follow this diagram, right? As per this diagram, whatever will be given to us as per the question, we are supposed to convert the given quantity into a number of moles, right? And just have a look. What is given to me as per the question? I'm given with the volume of the gas. This is my given quantity. So my first step is going to convert this given quantity into a number of moles. As simple as that, right? So my first step is going to calculate the number of moles of carbon dioxide. And we know, how do we convert volume into moles? We just divide it with 22.4, as simple as that. Yes, right? So I'll be writing given volume of the gas in liters divided by 22.4. The value comes out to be 3. So basically, I got the number of moles, right? My first step is done. From number of moles, I need to calculate the molecules. How do we convert moles into molecules? We just need to do one thing. We just need to multiply moles with Avogadro's number. I'll be getting the number of molecules. As simple as that, right? My second step, that is the calculation of molecules. I'll say number of molecules of carbon dioxide. It is going to be equal to number of moles of carbon dioxide multiplied by Avogadro's number. So these many molecules of carbon dioxide we have over here. Right? Okay, so I've solved the equation till here. What do I need to calculate actually? I need to calculate the atoms actually, right? Okay? So I've solved the equation till here. Now after this, what am I going to do? I'll be simply seeing how many atoms are there in one molecule of carbon dioxide. If I ask you how many atoms are there in one molecule of carbon dioxide, you'll say simply 3 atoms, right? 2 oxygen atoms, 1 carbon atom. So there are 3 atoms in one molecule of carbon dioxide. I'm going to write the same thing in the form of a statement. Right? Yes, have a look exactly. I'll be writing one molecule of carbon dioxide contains how many atoms? One molecule of carbon dioxide contains 3 atoms. Now people, it's simple. If one molecule of carbon dioxide contains 3 atoms, so 2 molecules will contain, multiplied by 2, 3 molecules will contain, multiplied by 3, 4 molecules, multiplied by 4, 3 Na molecules, multiplied by 3 Na. So I'll say 3 Na molecules of carbon dioxide will contain 3 multiplied by 3 Na atoms in total, which comes out to be 9 Na atoms. So I got to know exactly there are 9 Na atoms present in 67.2 liters of carbon dioxide, right? Very simple and basic thing, okay? Perfect. You got to know exactly how to calculate the atoms, right? Okay. These are the total atoms present in 67.2 liters of carbon dioxide, right? If in the question it was asked like how many oxygen atoms are there, right? If you're supposed to calculate exactly how many oxygen atoms are there in 67.2 liters of carbon dioxide, you'll be writing a statement. One molecule of carbon dioxide contains 2 oxygen atoms. 1 molecule of carbon dioxide contains 2 oxygen atoms. 2 molecules will contain into 2, 3 molecules into 3. So 3 Na molecules into 3 Na. So 6 Na oxygen atoms will be there in 67.2 liters of carbon dioxide. As simple as that, right? I can write it in the form of statement as well if you want. I can write it like this. I can say 1 molecule of carbon dioxide. 1 molecule of carbon dioxide contains how many oxygen atoms? It contains 2 oxygen atoms, right? If 1 molecule of carbon dioxide contains 2 oxygen atoms, so 3 Na molecules of carbon dioxide, 3 Na molecules of carbon dioxide will be containing 2 multiplied by 3 Na. The value comes out to be 6 Na oxygen atoms. So there are basically 6 Na oxygen atoms present in 67.2 liters of carbon dioxide. This part is also done, right? Now, what do I need to calculate the next? That is going to be the electrons. That is going to be the electrons, right? That is going to be the electrons. So I'm going to erase everything which is not needed, right? I'm going to erase everything which is not needed. In order to calculate the electrons, you should have the molecules, and you have already calculated the number of molecules. You have already calculated the number of molecules. Now it is time to calculate the number of electrons. Now exactly see how electrons are to be calculated. What do I need to do? I need to first of all calculate how many electrons are there in one molecule of carbon dioxide, right? I need to calculate exactly how many electrons are there in one molecule of carbon dioxide. See, if I talk about carbon dioxide, this is one carbon and two oxygen atoms, right? What is the atomic number of carbon? 6. What is the atomic mass? 12. This is 8. This is 16. This is 8. This is 16, right? So atomic number of carbon is 6. So in one atom of carbon, there are 6 electrons. In one atom of oxygen, there are 8 electrons. In one more atom of oxygen, there are 8 more electrons. The value comes out to be 22 electrons. So I must say, in one molecule of carbon dioxide, there are 22 electrons, right? As simple as that. In one molecule of carbon dioxide, there are 22 electrons. If I ask you, how many protons are there? How many protons are there? Whatever is going to be its atomic number, same is going to be the number of electrons, same is going to be the number of protons, right? So there are 6 protons in carbon dioxide, 8 plus 8 into oxygen atoms, the value comes out to be 22 protons as well, right? If I ask you, how many neutrons? You will say 12 minus 6 comes out to be 6. 16 minus 8 comes out to be 8. 16 minus 8 comes out to be 8. The value comes out to be 22 neutrons as well, right? You exactly got to know in one molecule of carbon dioxide how many electrons are there, how many protons are there, and how many neutrons are there, right? Now, I'll be writing a simple statement. I'll simply write something like this. I'll say one molecule. I'll write one molecule of carbon dioxide contains how many electrons? It contains 22 electrons. Yeah? One molecule of carbon dioxide contains 22 electrons. But do I have only one molecule of carbon dioxide? No way. We have got some 3 Na molecules, yeah? If one molecule of carbon dioxide contains 22 electrons, I must say 3 Na molecules of carbon dioxide will contain 22 multiplied by 3 Na. The value comes out to be 66 Na electrons. Similarly, if I ask you how many protons are there, you will say one molecule of carbon dioxide contains 22 protons. So 3 Na molecules of carbon dioxide will contain 66 Na protons. If I'll ask you how many neutrons will be there, you will say one molecule of carbon dioxide will contains 22 neutrons. So 3 Na molecules will contain 22 multiplied by 3 Na neutrons. Is that clear to everyone? Right? A very simple and basic question this was. You guys can let me know in the chats fast if it is clear to every single guy so that I can move on to a few more. Yeah? Let me know fast. It's a very simple and basic question, yeah? Perfect. All right, so let's move on. Let's try to do one more question so that it completely gets clear to you, yeah? Okay, this was the question which we solved, and this is its solution which you are going to get in the Telegram group in the form of PDF, yeah? Okay, let's try to solve one more. This is one more question. Again a similar type of question. Have a look exactly how do we approach this. Calculate the following in 1.8 grams of glucose. So basically, I'm given with glucose, right? I'm given with glucose. And how many grams of glucose are given? 1.8 grams of glucose, yeah? So what is given to me as per the question? What is given to me as per the question? I'm given with the mass of glucose. I'm given with the mass of the glucose. What do I need to calculate exactly? Atoms, electrons, neutrons, right? I'm going to follow the diagram which I gave you a few minutes back, yeah? Right, people? I'm going to follow the same diagram which I gave you a few minutes back. So what is the first step which I'll be doing? I'll be converting the given quantity into number of moles, right? So first of all, I will be calculating the number of moles of glucose, yeah? I will be calculating the number of moles of glucose, which is going to be equal to mass of glucose in grams divided by molar mass of glucose. When you calculate, it comes out to be 180 grams per mole, right? The value comes out to be 0.01. So my first step is done. I'm done with the calculation of moles. What is the second step? From moles to molecules, yeah? So I'll be calculating the number of molecules of glucose. The number of molecules of glucose. Right? How do we convert moles into molecules? We just multiply the moles with the Avogadro's number. We just multiply the moles with the Avogadro's number. We get the number of molecules. So these many molecules of glucose we have over here. Right? I got the molecules. Yes. Now, it's the time to calculate the atoms first of all. Let's try to calculate atoms. First of all, I'll be saying in one molecule of glucose, how many atoms are there, right? Let's check it out. See, if I talk about the one molecule of glucose, C6H12O6, right? There are 6 carbon atoms, 12 hydrogen atoms, 6 oxygen atoms, so 12 plus 6 comes out to be 18 plus 6, 24. So there are basically total 24 atoms in one molecule of glucose, right? As simple as that. Yeah? Now I'm going to write the same thing in the form of a statement. The question will be done and dusted. I'll say one molecule of glucose contains how many atoms in total? It contains 24 atoms in total. If one molecule of glucose contains 24 atoms, do I have one molecule of glucose? No way. We have got 0.01 Na molecules of glucose, right? So if one molecule of glucose contains 24 atoms, I must say 0.01 Na molecules of glucose will contain 24 multiplied by 0.01 Na atoms in total, right? So the value will be 0.24 Na atoms, correct? So these many total atoms will be there in 1.8 grams of glucose. As simple as that. Perfect? Right? I'm sure it's clear to everyone. You got to know exactly how many total atoms are there, right? For example, total atoms were not asked. You were only asked to calculate the number of carbon atoms, right? Then you will write a statement. One molecule of glucose contains 6 carbon atoms. One molecule of glucose contains 6 carbon atoms. So 0.01 Na molecules will contain 6 multiplied by 0.01 Na atoms. So the answer is going to be 0.06 Na carbon atoms, right? Similarly, 0.12 Na hydrogen atoms. Similarly, 0.06 Na oxygen atoms, right? Just let me know in the chats if it is clear to everyone, yeah? Let me know first. Let me know first. Absolutely, guys, absolutely. Yes, perfect. Should I be moving ahead? Should I be moving ahead? Perfecto, wonderful. Okay, let's have a look like exactly how to calculate the electrons and neutrons. Electrons I'm going to calculate, neutrons you guys are going to calculate on your own, right? Electrons I'll calculate, neutrons you guys will be calculating. Okay, have a look. Now what I'll be doing, I'll be exactly seeing how many electrons are there in one molecule of glucose, right? Now exactly I'll be seeing how many electrons are there in one molecule of glucose. Have a look. Carbon has got the atomic number of 6, atomic mass of 12. This is 1, this is 1. Oxygen, this is 8, and this is 16, right? So in one atom of carbon, these are the value of atomic numbers, right? And whatever are the atomic number values, same is going to be the number of electrons and protons if it is going to be electrically neutral, right? Have a look exactly what I'm going to talk about now. If I talk about one carbon atom is going to have 6 electrons, right? But there are 6 carbon atoms, so multiplied by 6. Similarly, one hydrogen atom is going to have 1 electron, and there are some 12 hydrogen atoms, right? Similarly, one oxygen atom is going to have some 8 electrons, and there are 6 oxygen atoms. So it's going to be 36 plus 12 plus 48. How much it comes out to be? 8, 2, 10, 6, 16, 3, 1, 4, 5, 4, 9, 96, right? So I got to know exactly one molecule of glucose. I got to know exactly like one molecule of glucose contains how many electrons? It contains 96 electrons. If one molecule of glucose contains 96 electrons, but do we have only one molecule of glucose? No way. We have got some 0.01 Na molecules of glucose, right? So if one molecule of glucose contains these many electrons, so I must say 0.01 Na molecules of glucose will contain 96 multiplied by 0.01 Na electrons, right? So these are the total number of electrons which will be there in 1.8 grams of glucose, right? If I'll ask you how many protons will be there, again you will say one molecule of glucose contains 96 protons. So 0.01 Na molecules will again contain these many protons. And neutrons, you guys are going to calculate on your own. If it is clear to everyone, you guys can let me know in the chat so that I can move on to the next part. First, yeah? Let me know in the chats, my dear people. Right? Let me know fast in the chats if it is clear to everyone. Perfect? Okay. All right. So let's move on then. Let's go ahead. And let's try to solve this question. Again, a very simple question this is. We are given with 0.1 moles of AlCl3. We need to calculate the total number of ions. People, do you know how this AlCl3 dissociates? Do you know that? Do you know how AlCl3 dissociates? It dissociates as Al positive plus 3 times Cl negative, right? This is something which you all must be knowing. Yeah? AlCl3, how it dissociates? It dissociates as Al positive and 3 times Cl negative, right? If I ask you, how many ions are there in total? How many ions are furnished by one molecule of AlCl3? You will say it has given some 1 cation and 3 anions, right? So I'll be clearly writing one statement. I'll be writing one molecule of AlCl3 furnish some 4 ions in total. Right? Okay, I got to know one molecule of AlCl3, it furnished some 4 ions in total. If I ask you how many molecules of AlCl3 total we have, we are already given with the moles of AlCl3. First of all, let's calculate the molecules. How do we calculate the molecules? Multiply the moles with Avogadro's number, right? So basically, there are some 0.1 Na molecules of AlCl3, right? We got to know one molecule of AlCl3 contains 4 ions. So 2 molecules will contain into 2, 3 molecules multiplied by 3, 0.1 Na molecules multiplied by 0.1 Na, right? It's going to be 4 multiplied by 0.1 Na ions. So these many ions will be there in total in 0.1 moles of AlCl3. You guys can let me know first if it is clear to everyone. Yes, perfect. Exactly. Simple. Right, people? If I ask you how many anions will be there, only anions, you will say one molecule of AlCl3 gives some 3 anions. So 0.1 Na will be furnishing some 3 multiplied by 0.1 Na, right? So those many anions will be there. Perfect? Okay. So let's move on then. These were some simple basic questions, yeah? And I'm sure these basic questions are clear to you. Now let's actually move on to the actual topic which we are going to cover in the tonight's session basically, right? This was all basics, right? Which was linked with your last session, correct? Let's exactly see now this topic which is very important and frequently you use this topic in other chapters of physical chemistry as well. This is average molar mass of a gaseous mixture, right? This is average molar mass of a gaseous mixture. Have a look. For example, I'm taking a container. Understand properly what I'm going to talk about. Let's say this is the container which I have, okay? This is the container. Let's assume this container contains some 3 chemically non-reacting gases. Gas 1, gas 2, gas 3. These are some 3 chemically non-reacting gases present in the container. 3 chemically non-reacting gases in the container. That means these gases are not reacting and forming some new product, right? These are chemically non-reacting, which I'm assuming, okay? Let's assume the mass of gas 1 in the container is W1 grams, mass of gas 2 in the container is W2 grams, mass of gas 3 in the container is W3 grams, right? W1 is the mass of gas 1 in the container, W2 mass of gas 2 in the container, W3 mass of gas 3 in the container, right? Let's assume the number of moles of gas 1 in the container is N1, number of moles of gas 2 in the container is N2, number of moles of gas 3 in the container is N3. This is something which I'm assuming as well. Let's assume there are some N1 moles of this gas in the container, N2 moles of this gas in the container, N3 moles of this gas in the container, right? This is something which I'm assuming. Let's assume the molar mass of gas 1 is M1, molar mass of gas 2 is M2, molar mass of gas 3 is M3, okay? Remember, whenever you will be having a mixture of gas present in the container, this is a mixture of gas. It's a gaseous mixture, right? The container contains more than 1 gases, right? And whenever in the single container you'll be having more than 1 gas, you can clearly say that we have got a gaseous mixture in the container. And for the gaseous mixture, we always calculate one more term, right? We define one more new term that is called as average molar mass of the gaseous mixture. That's what we call as average molar mass of gaseous mixture. So for this gaseous mixture, I'll be defining a new term that's represented by MAV. MAV is called as average molar mass of the gaseous mixture, right? Now have a look exactly what I'm going to talk about. If I ask you, how many moles are there in the container? How many total moles are there in the mixture? You'll say N1 plus N2 plus N3, right? If I'll ask you, what is going to be the mass of the mixture? What is going to be the mass of this whole mixture? You'll say W1 plus W2 plus W3, right? That's something which you'll say, right? Okay. Simple. Now have a look exactly. I'm writing a formula, simple formula I'm writing total moles present in the mixture. I'm writing total moles present in the mixture. How do we calculate moles? Given mass by molar mass, right? I'm talking about the total moles present in the mixture. That is going to be equal to mass of the mixture divided by molar mass of the mixture. And what do we call molar mass of mixture as? We call it as the average molar mass, right? Yes? Perfect. Now, have a look. Can I calculate M average from here? Can I say M average is going to be equal to mass of the mixture divided by number of moles present in the mixture? Yes? Mass of the mixture is nothing, W1 plus W2 plus W3. Moles present in the mixture is N1 plus N2 plus N3. So I'm getting one simple formula to calculate average molar mass of the gaseous mixture. It is going to be equal to mass of the mixture, which is W1 plus W2 plus W3 plus dash dash dash. How many gases will be there? Divided by what? Divided by total moles present in the mixture, which is going to be N1 plus N2 plus dash 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 something something. Let's assume there are 5, 6, 7, 8 gases in the container, right? That's why I'm kept this dash 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 over here. Yes? Now, let me tell you, this is the first formula by means of which you can calculate the average molar mass of the gaseous mixture, right? This is the first formula by means of which you can calculate the average molar mass of the gaseous mixture. Point number 1. Point number 2. Let's assume you are not given with these individual masses. Let's assume you are not given with the mass of gas 1 in the container, mass of gas 2, mass of gas 3 is not given to you. What do you do at that time? What do you do at that time? People, do you know number of moles is equal to given mass divided by molar mass? This is something which everyone will be knowing, right? If I write N1, what is N1? Number of moles of gas 1 in the container, which is equal to mass of gas 1, molar mass of gas 1. As simple as that, yeah? So can I get W1 from here? Can I say W1 is simply going to be equal to N1 multiplied by M1? Yeah? Similarly, can I calculate W2? W2 is going to be equal to M2 N2. W3 is going to be M3 N3. As simple as that. We can write it in this way as well, no issues at all. Correct? Right? Now, what I'm telling you, I'm simply telling you if W1, W2, W3 is not given to you, if the individual masses of the gases are not given to you, what do you do at that time? Instead of W1, you'll be writing M1, N1. Yeah? So you got one more result. MAV, average molar mass of the gaseous mixture, will be equal to M1, N1 plus M2, N2 plus dash, dash, dash divided by what? Divided by simple N1 plus N2 plus something like this. This is one more result by means of which you can calculate the average molar mass of the gaseous mixture. Right? This is one more result by means of which you can calculate the average molar mass of the gaseous mixture. Correct? Let's talk about one more result. Then we'll be doing some questions based on it, right? I'm giving you one more result. What is that? See, first of all, I have got the gaseous mixture in the container. Let's assume this gaseous mixture, it is present at constant pressure and temperature. Its pressure and temperature is kept fixed. Its pressure and temperature is kept fixed. Let's assume that. Let's assume the pressure and temperature of this gaseous mixture is not changing at all. It's kept fixed. It's kept constant, right? What do I do at that time? Have a look exactly. Do you remember the ideal gas equation PV is equal to nRT? You might be remembering absolutely, right? Because you have just now given the NEET. Okay, have a look exactly. What have I done? I have taken the gaseous mixture and I have kept its pressure and temperature constant, fixed. The pressure of the mixture and temperature of the gaseous mixture I'm keeping fixed, right? R value is already fixed. Can I say volume is directly proportional to moles, right? Can I say under these conditions volume is directly proportional to moles? Yes. So wherever you see moles in this formula, you can replace the moles by its corresponding volume. What does that mean? That means I'm getting one more formula to calculate average molar mass of gaseous mixture, but this formula which I'm going to write, it's only valid when the pressure and the temperature of the gaseous mixture is kept fixed. And what is the formula all about? It's going to be equal to M1 multiplied by, instead of N1, you'll be writing V1 plus M2 V2 plus M3 V3 dash 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 divided by N1 plus N2 plus N3. Instead of that, V1 plus V2 plus dash dash like this, yeah? Okay, so this is one more formula by means of which we can calculate the average molar mass of the gaseous mixture. But this formula you are going to use only if the pressure and temperature of the mixture is constant, right? Simple? Correct? Right, people? Let me give you one more formula then. Let me give you one more formula from which one more question can be asked. See what the formula is going to be all about. I'm assuming, for example, there are only two gases in the container. This is something which I'm assuming now. Let's assume there are only two gases in the container. Correct? Have a look exactly. If there are only two gases in the container, I can write the formula MAV is equal to M1 N1 plus M2 N2 divided by N1 plus N2. This is one of the formulas by means of which we can calculate average molar mass of the gaseous mixture. Yeah? Now see, I'm going to write it like this. MAV is equal to, I'm writing it as M1 N1 divided by N1 plus N2 plus M2 N2 divided by N1 plus N2. I can write it like this as well. Okay? I'm simply dividing this M1 N1 with the denominator separately and dividing this term with the denominator separately, right? People, do you know what do we call this term N1 divided by N1 plus N2? And what do we call this term N2 divided by N1 plus N2? You would have studied it somewhere. I can say MAV, average molar mass of the gaseous mixture, is equal to M1 multiplied by number of moles of gas 1 in the container divided by total moles present in the container. Do we call it as mole fraction? So it's going to be mole fraction of gas 1, right? Plus, it's going to be M2, which is already there, N2 divided by N1 plus N2. Number of moles of gas 2 in the container divided by total moles present in the container. Do we call this as mole fraction of gas 2? Absolutely, we call this as mole fraction of gas 2. So this is one more result which you guys are going to remember in order to calculate what? In order to calculate the average molar mass of the gaseous mixture, right? Let me summarize this all. Just remember the formulas and we are going to do the questions. That's all, yeah? Right? Have a look exactly, guys. Whenever you'll be having two or more than two chemically non-reacting gases in the container, at that time you will be calculating the average molar mass of the gaseous mixture, right? And there are four results which I gave you, which I'm going to give you to calculate its average molar mass. The first result, average molar mass of the gaseous mixture is equal to W1 plus W2 plus dash dash divided by N1 plus N2 plus dash dash, right? Okay, this is the first result. W stands for mass, N stands for moles, correct? Second formula to calculate average molar mass of gaseous mixture, it's going to be equal to M1 N1 plus M2 N2 plus dash dash divided by what? Divided by N1 plus N2 plus something, yeah? The third formula, which is only valid when the pressure and temperature of the gaseous mixture is kept constant, right? And that is M1 V1 plus M2 V2 plus divided by V1 plus V2. This is the next result. Next result, average molar mass of the gaseous mixture is equal to M1 multiplied by Chi1 plus M2 multiplied by Chi2 plus dash dash. These are the four results which you guys are going to use in order to calculate the average molar mass of the gaseous mixture, yeah? Perfecto? Right, people? Do remember one more thing. This is something which I'm telling you so that you won't make any mistake in the questions based on the average molar mass. And this average molar mass, it is frequently used in the other chapters of physical chemistry as well. Okay? Have a look, guys. Let's say there is gas 1 and gas 2 in the container. Let's assume there is gas 1 and gas 2 in the container. So basically, again, I've got the mixture of gas. Let's assume the average molar mass of this gaseous mixture I'm representing by MAV. Right? Okay? Now, I'm writing a term over here that is mole percent. If I write mole percent of 1, what it means? It is nothing. Mole percent of 1 means mole fraction of gas 1 multiplied by 100. That's all. That's all. If I write mole percent of gas 2, that's again nothing. It is a mole fraction of gas 2 multiplied by 100. Correct? This result you can convert into another one as well, right? You can say average molar mass of the gaseous mixture is equal to M1. What was the Chi 1? What is Chi 1? Mole fraction of gas 1. Mole fraction of gas 1. Can I say mole fraction of gas 1 is equal to mole percent of gas 1 divided by 100? Absolutely. It's going to be mole percent of gas 1 divided by 100. Yes. Plus M2 multiplied by, what is this Chi 2? Chi 2 is mole fraction of second. Mole fraction of second. Can I say mole fraction of second is mole percent of second divided by 100? Yes, it is mole percent of second divided by 100. You can use this result as well. Now it's entirely your wish to use the result. You need to look at the question. If the masses of individual gases are given, this is the way to calculate average molar mass of the gaseous mixture, right? If the individual moles of the gases are given, this is the result which you guys are going to use. If the pressure and temperature of the mixture is kept constant, this is the result which you guys are going to use. If mole fraction of the gases are given, this is the result you are going to use. And if mole percent of the gases are given, this is the result which you guys are going to use, right? You guys can let me know in the chats if every single thing is clear so that I can move on to the questions which are based on these concepts, yeah? It's a little cold here, right? Perfect. So I'm going to give you the questions, and by solving those questions, I'm sure all this is going to get clear to you, right? Let's try to solve certain questions. And by means of those questions, it is definitely going to be, right? The concept is going to get cleared, okay? See guys, how these questions are to be solved. These are the formulas which are mentioned, right? Okay, this is the first question which is on your screen. Let's try it out. Let's try it out. Or before doing this question, let me give you one simpler question. Let me give you one simpler question, right? I'm writing the question on my own, okay? Let's start with a simple question, then we'll scale up slowly. The question is like this. Calculate the average molar mass of the gaseous mixture containing 4.4 grams of gas A whose molar mass is 44 grams per mole, comma 6.4 grams of gas B whose molar mass is 64 grams per mole, right? And 4.8 grams of gas C whose molar mass is 48 grams per mole. And the three gases I'm assuming as chemically non-reacting. These are chemically non-reacting gases, right? These are chemically non-reacting gases. I need to calculate the average molar mass of the gaseous mixture. Let's have a look. As for the question is concerned, we are given the container, and this container contains three chemically non-reacting gases, gas A, gas B, and gas C. I am given with the mass of gas A, which I represent by W1. Mass of gas A is given to me, 4.4 grams. Mass of gas B in the container, which I represent by W2, that is given to me, 6.4 grams. And mass of gas C, which I'm given with, it is 4.8 grams, right? It is 4.8 grams. This is something which is given to me as the equation, yeah? This is something which is given to me as the equation. Now have a look. Molar mass of gas 1, I'm given with 44 grams per mole. Molar mass of gas 2, I'm given with 64 grams per mole. Molar mass of gas 3, I'm given with, that is 48 grams per mole. Every single thing is given to me, right? Every single thing is given to me. See, I'm given with the individual mass of the gases. I'm given with their molar masses as well. What do I need to calculate? I need to calculate the average molar mass of the gaseous mixture. And whenever individual masses of the gases will be given to us, and we will be supposed to calculate the average molar mass of the gaseous mixture, which result we are going to use? We are going to use the result W1 plus W2 plus W3 divided by N1 plus N2 plus N3. As simple as that, right? W1 is given to me as 4.4. W2, that is given to me as 6.4. W3, that's given to me as 4.8 divided by N1. What is N1? number of moles of gas 1 in the container, right? Number of moles of gas 1 in the container will be equal mass of gas 1 divided by molar mass of gas 1 plus number of moles of gas 2, mass of gas 2, molar mass of gas 2, mass of gas 3, molar mass of gas 3, right? Do we know the value of W1? Yes, we know. Do we know the value of M1? Yes, we know. W2 we know, M2 we know, W3 we know, M3 we know. Just put all the values over here, get the average molar mass of the gaseous mixture. Isn't it simple, my dear people? Isn't it simple? Yeah? Perfect. And the ones who have just joined in who not like the video, please do like the video, share the video with friends, and do subscribe to the channel as well. Okay? Devanshi is asking, sir, which state you are in right now? I am live from Srinagar, Jammu and Kashmir. Yeah? Perfect. All right. So let's move on. Let's try to do certain questions from the topic average molar mass of the gaseous mixture. Have a look exactly how this sort of equation is to be solved. It's a very simple one. Trust me on that. See you guys. Okay. The question says at 27 degrees centigrade and 1 atm. Do you know why these two parameters are given to you? Do you know that? Do you know that? There is only one formula by means of which we can calculate average molar mass of the mixture when the pressure and temperature of the mixture is kept constant. That is in terms of volume, M1 V1 plus M2 V2, right? So basically in this question, if you are supposed to calculate average molar mass, which formula you are going to use? You are going to use the formula M1 V1 plus M2 V2. As simple as that, right? Now have a look. At 27 degrees centigrade and 1 atm pressure, a given mixture of O2 and SO2. So basically I'm making a container over here, and in this container you have got O2 gas and SO2 gas, correct? Contains gases in 2:1 volume ratio. The volume ratio of these gases are given to us as 2:1. We are given with the volume ratio of the gases 2:1, right? Calculate the moles present in 20 grams of the mixture. I am given with the mass of mixture as well. Mass of mixture I am given with as 20 grams. I need to calculate how many total moles are there in the container which contains 20 grams of the mixture. How many total moles are there in 20 grams of the mixture if O2 and SO2 are present in the volume ratio of 2:1? Yeah? Let's have a look. Let's have a look. First of all, I need to calculate the total moles present in the mixture. Can I say total moles present in the mixture is going to be equal to mass of the mixture divided by molar mass of the mixture. And what do we call the molar mass of the mixture as? We call it as the average molar mass, right? We call it as the average molar mass. So in order to calculate the total moles present in the mixture, you should have the value of mass of mixture, which is given to be as 20, and at the same time you need to calculate the average molar mass of the gaseous mixture. So first of all, I'm in need to calculate average molar mass of the gaseous mixture. Once I get it, I'll put it over here. I'll be getting the total moles present in the mixture, right? Now the point is, how do we calculate the average molar mass of this gaseous mixture? Have a look exactly. Let me call this oxygen as gas 1. Let me call this as gas 2. Do we know the molar mass of gas 1? Do we know the molar mass of O2? Absolutely, we know it, 32 grams per mole. Molar mass of gas 2, it is 64 grams per mole. We are given with their volume ratio as well. I'm directly representing the volume ratio as V1 and V2. As simple as that. I'm directly mentioning the volume ratio as V1 and V2. Do we know the formula to calculate the average molar mass of the gaseous mixture? Yes, we know it. It is going to be equal to M1 V1 plus M2 V2 divided by V1 plus V2. People, do we know the value of M1? Yes, we know the value of M1, that is 32. V1, that is 2. So 32 multiplied by 2. 32 multiplied by 2, 64 plus M2 V2, 64 multiplied by 1, 64. So 64 plus 64 comes out to be 128 divided by V1 plus V2 comes out to be 3. So this is basically the average molar mass of the gaseous mixture, right? You got to know the average molar mass of the gaseous mixture, right? Put this value of average molar mass in this equation. You are done. 20 divided by average molar mass of the gaseous mixture is 128 by 3. 3 comes up. So the final result is 60 divided by 128. So these many total moles will be there in the container, right? Which is something I was supposed to calculate. You guys can let me know. Yes, it's going to come as 0.4 something, right? Something like that. You guys can let me know in the chat if it's clear to every single guy so that I can move on to one more question. Hanji, you can write it as 15 by 32 as well, no issues. Perfect. All right, so let's move on then to one more question. Let's move on then to one more question. Exactly, it's 60 divided by 128 is coming as the answer. Yeah? Moving on to one more question. This is one more question, right? If you just remember the formula, you can kill this one now, right? No need to use your brains or something. It's a very simple and basic one, if you remember the formula, which I gave you a few minutes back. A gaseous mixture contains 60 mole % of carbon dioxide and 40 mole % of oxygen. So basically, this is the container, and this container contains two gases. One is carbon dioxide, and at the same time, you have got oxygen. It contains two gases, carbon dioxide and oxygen, yeah? Okay. Now, let me call this carbon dioxide as gas 1, let me call this as gas 2. Do we know their individual molar masses? Yes, we know. What is the molar mass of carbon dioxide? It is 44 grams per mole. What is the molar mass of oxygen? It is 32 grams per mole, right? As for the question, what am I given with? I am given with the mole % of both the gases. I am given with the mole % of both the gases. And few minutes back, I told you, mole % of a particular gas is always equal to mole fraction of the gas multiplied by 100. Right? Simple. I told you a few minutes back only. Mole % of a particular gas is always equal to its mole fraction multiplied by 100. I am given with the mole % of carbon dioxide, which is given to me as 40. I am given with the mole % of oxygen as well. Sorry, this is 60, right? This is 60, just a second. Mole % of carbon dioxide, it's given to me as 60. Mole % of oxygen, it's given to me as 40. If I know their mole %s, can I calculate their mole fractions? Yes, I can do that. So mole fraction of gas 1 is equal to mole % divided by 100, 60 by 100, 0.6, 40 divided by 100, 0.4. This is Chi2, mole fraction of gas 2. There is one formula by means of which you can calculate the average molar mass of gaseous mixture by using the mole fraction data, right? That is MAV is equal to M1 Chi1 plus M2 Chi2. Few minutes back only, I gave you this result. M1 value, it's given to me as 44, Chi1 value, 0.6, M2 value, that's given to me as 32, Chi2 value, 0.4, solid, that's going to be your answer, as simple as that. And as far as I remember, the answer will come out to be 39 point something. You guys can let me know in the chat if it's clear so that we can move on to one more question, yeah? Perfect. All right, moving on to one more then. So the final answer is coming out to be 39.2 grams per mole, yeah? Okay, this is one more question, right? And it's a bit lengthier one, right? Let's try to solve this question as well. See guys, how this sort of equation is to be solved. Understand properly. All the things you guys are going to understand properly. The equation says 600 ml mixture of O2 and O3 gas at STP weighs 1 gram. Calculate the volume of the mixture. What? The equation should be calculate the volume of, the equation should be calculate the volume of O3 in the mixture. Calculate the volume of O3 or O2 in the mixture, something like that. The equation should be calculate the volume of O3 or O2 in the mixture. That should be the equation. Yeah? Perfect. 600 ml mixture of O2 and O3 gas at STP weighs 1 gram. Calculate the volume of O3 in the mixture. That is the question. Let's see how exactly this question is to be solved. Have a look properly. Step by step we are going to do this question. Yeah? See guys. For example, this is the container which I have taken, right? This is the container which I have taken. This container, it contains two gases. Which one? It contains O2 gas and at the same time it contains O3 gas. So two gases this container contains, right? So basically there's a mixture of gases in the container, right? There's a mixture of gas in the container, right? Have a look. What is given to us? We are given with the mass of this gaseous mixture, right? We are given with the mass of the gaseous mixture, which is given to me as 1 gram. So 1 gram is the mass of gaseous mixture, right? we are given with the volume of this complete mixture as well. Volume of this mixture I'm given with as 600 ml, right? Volume of this whole mixture is given to be as 600 ml. Let's assume out of 600 ml, there are some x ml of O3 in the container. So the remaining is going to be 600 minus x ml, right? Okay, I assumed if 600 ml is the volume of complete mixture, out of 600 ml, let's assume there are some x ml of ozone and 600 minus x ml of O2 in this container, correct? Yes? Now have a look. Now have a look exactly. This mixture is present at STP. The gaseous mixture is present at STP, right? That means the pressure and temperature of this mixture is kept fixed. It's constant. The pressure of the mixture is given to us. The pressure of the mixture will be 1 bar and temperature of this mixture will be 0 degrees centigrade or 273 Kelvin because it is STP condition that's given to us, right? This mixture is present at STP. Okay. Now have a look what I'm going to do. If I write something like this, number of moles present in the mixture will be equal. Number of moles present in the mixture. Am I given with the mass of mixture? Yes. It is going to be mass of the mixture divided by molar mass of the mixture. But this is a gaseous mixture, right? What do we call the molar mass of gaseous mixture as? We call it as the average molar mass. So I'm dividing it with MAV, correct? This is something which I'm writing till now. I'm given with the mass of the mixture, right? Given mass of the mixture divided by molar mass of the mixture. And molar mass of the mixture is what we call as average molar mass. I'm sure it's clear to you, right? Am I given with the volume of the mixture? Yes, I am given with the volume of the mixture. And volume of the mixture I'm given with as 600 ml. Volume of the mixture is given to me as 600 ml. Okay? And the mixture is present at STP. I can write one more thing. I can again calculate the total moles present in the mixture using volume data. I can say total moles present in the mixture is going to be equal to given volume of the mixture, which is 600 ml, divided by 22400. So the value comes out to be 6 upon 224. Do you agree with this? This term is giving you the total moles present in the mixture. Even this term is giving you the total moles present in the mixture, right? Okay. So if both the terms are same, can I directly equate the two? I can do that, yeah? Absolutely, I can do that. I can write 1 upon MAV is equal to 6 upon 224. Can I say MAV is equal to 224 divided by 6? This is the average molar mass of the mixture which I got. But am I supposed to calculate average molar mass of the mixture? No. I am supposed to calculate volume of ozone in the mixture. I'm supposed to calculate volume of ozone in the mixture. That's what I'm supposed to calculate, okay? If I call this oxygen gas as gas 1, I call this as gas 2. What is the molar mass of gas 1? What is the molar mass of oxygen? That is 32 grams per mole. What is the molar mass of ozone, which I represent by M2, which is 48 grams per mole? I'll be directly calling this as V1. I'll be directly calling this as V2, right? Yes. So instead of MAV, can I write M1 V1 plus M2 V2 divided by V1 plus V2? This value is equal to 224 divided by 6. Yes? Perfect. Now, M1 value is given to me as an equation, that is 32. V1 value is given to me as 600 minus X. M2 value is given to me as 48. V2 value is X divided by V1 plus V2. V1 plus V2 is basically volume of whole mixture. Volume of whole mixture is 600 ml. And this value comes out to be 224 divided by 6. Can I say you just got one equation which contains just one unknown? Right? Can I say you got one equation which contains one unknown? And what is the unknown? Unknown is X. Right? By solving this equation, can we get the value of X? Absolutely, you can get the value of X. And as far as I remember, X value, you'll be getting it as 200 ml. What was X? X was the volume of O3 in the mixture. X was the volume of O3 in the mixture. If you got to know the volume of ozone in the mixture, can you calculate volume of oxygen in the mixture? You can do that too. You can write volume of oxygen in the container is going to be equal to 600 minus X. So 600 minus 200, the value comes out to be 400 ml. You guys can let me know in the chats if it is clear to everyone, yeah? You guys can let me know. You guys can let me know fast in the chats if it is clear to every single guy. Yeah? Okay. Perfect. Perfecto again. Right, my dear people? How much is the temperature in Jammu? I'm not in Jammu, I'm in Kashmir, right? Jammu is like 300 kilometers far from Srinagar. And the temperature currently will be 2-3 degrees centigrade, something like that. Yeah? Okay, so I'm sure this question is clear to you. So let's move on to something called as stoichiometry. Okay? Let's move on to something called as stoichiometry. One of the most important concepts from the chapter mole concept. People, is the average molar mass of gaseous mixture clear to you? You can honestly let me know fast. Vidya, there is a link in the description box of the video. You need to click on that link. You will be automatically joining my batch, right? People, just let me know in the chats first if this average molar mass of the gaseous mixture is clear to you. Yeah, I want everyone to say it. Uzair, bro, you can just drag the video a little back. It'll be a replay for you. Okay. All right, so the ones who have got any sort of problem, you can just drag the video back. It'll be a replay for you. And after that, if you still be having any issues in understanding the question, you can write in the comment section afterwards. Yeah? Okay. All right, so let's get going. Let's get started with something called as stoichiometry. Okay? What this stoichiometry is all about? Where do we use this concept of stoichiometry? It's a very important concept right? It's a very important concept. Frequently, you use this concept in different chapters, right? You use stoichiometry in equilibrium, states of matter, thermodynamics, right? Everywhere, chemical kinetics, okay, even solutions. You use this concept everywhere. So let's exactly master this concept, right? Let's have a look exactly what the stoichiometry is all about and how to approach to these sort of questions which are based on stoichiometry, okay? For example, I am taking a chemical reaction. The chemical reaction is N2 gas plus H2 gas. It gives NH3 gas. This is the reaction which I'm taking. This is the reaction which I'm taking, right? Yes? I'm taking a general reaction. N2 is reacting with H2 and it forms NH3. Is it a balanced chemical equation? It's not a balanced chemical equation. Let's try to balance it. This should be 3 times. This should be 2 times. And this is 1 over. It's a balanced chemical equation now, right? It's a balanced chemical equation now, right? This 1, 3 and 2, these are called as the stoichiometric coefficients. 1, 3 and 2, these are called as the stoichiometric coefficients, right? Okay? These are called as stoichiometric coefficients. Now what you guys are going to do, you guys are going to treat these stoichiometric coefficients as moles. You guys are going to treat these stoichiometric coefficients as moles. When you treat these stoichiometric coefficients as moles, you can clearly say 1 mole of N2. You can clearly say 1 mole of N2 completely reacts with 3 moles of H2 and produces 2 moles of NH3. Produces 2 moles of NH3. You are going to treat these stoichiometric coefficients as moles, and after balancing the reaction, after getting the stoichiometric coefficients, you can write this statement in terms of moles, right? You can say 1 mole of N2 completely reacts with 3 moles of H2 and produces and gives 2 moles of NH3, right? Now, one more thing, one more statement you can write. People, if I ask you, what is the molar mass of N2? What is the molar mass of N2? You'll clearly say molar mass of N2 is 28 grams. What does that mean? That means mass of 1 mole of N2 is 28 grams, right? Yes, as simple as that. If I ask you, what is the molar mass of N2? You'll say molar mass of N2 is 28 grams. What do we mean by the term molar mass of N2? That means mass of 1 mole of N2. Mass of 1 mole of N2 is 28 grams. Do I have 1 mole of N2? Yes, we have 1 mole of N2. What's going to be its mass? It's going to be 28 grams, right? If I ask you what is the molar mass of H2, you'll say 2 grams, right? 2 grams. 2 grams is the molar mass of H2. Or I can say 2 grams is the mass of 1 mole of H2, right? But do I have 1 mole of H2 or 3 moles? I have 3 moles of H2. If the mass of 1 mole of H2 is 2 grams, so mass of 3 moles of H2 is simply going to be 6 grams. Yeah? If I ask you, what is the molar mass of NH3? You'll say molar mass of NH3 is 17 grams. What does that mean? That means mass of 1 mole of NH3 is 17 grams. But do I have 1 mole or 2 moles? I have 2 moles. So 17 multiplied by 2 comes out to be 34 grams, right? So you can say something like this: 28 grams of N2, 28 grams of N2 completely reacts with 6 grams of H2, 6 grams of H2 and produces 34 grams of NH3. This statement I wrote in terms of moles directly. This statement I wrote in terms of mass. I can write one more statement as well, but that is going to be in volume now, right? I can treat these stoichiometry coefficients directly as volume as well, okay? I can say 1 volume of N2, 1 volume of N2 completely reacts with 3 volume of H2 and liberates 2 volume of NH3, right? What does that mean? You can take this volume in liters. You can say 1 liter of N2 completely reacts with 3 liters of H2 and liberates 2 liters of NH3. No issues at all. Yeah? Okay? Correct? The first statement is in terms of mole. Second statement in terms of mass. Third statement in terms of volume. Now let's try to use all these statements one by one and try to solve the equations based on these 3 statements. These 3 statements only you guys are going to use and solve the equation. That's all. Okay? I'm starting with the simplest question, the simplest question which we have. This is the simplest question among all, right? The question says, calculate the mass of O2 gas produced on heating 12.25 grams of KClO3 at STP, right? So as per the question, I am heating KClO3. Simplest question this is. As per the question, I'm heating KClO3. When we heat this KClO3, right? When we heat this KClO3, it gets converted into KCl solid and you get oxygen gas as well. This is the reaction which will happen when you guys are going to heat up this KClO3. On heating this KClO3, it gets converted to KCl and with this you get oxygen gas as well. If I ask you, is the reaction balanced or not? The reaction is not balanced yet, right? The reaction is not balanced yet. So first of all, let's balance the reaction. This should be 2 times. This should be 2 times, this should be 3 times. I balance the reaction, right? Now it's going to be your wish to use any of the method, either mole method or mass method or volume method, okay? Better to solve the equation by means of mole method, right? What I'll be doing over here, remember after balancing the reaction, if you are using the mole method, I gave you 3 methods. One is mole method, mass method, volume method, right? If you are using the mole method, first thing, you are supposed to balance the reaction. That's something which you have done. Second, whatever will be the given quantity, convert the given quantity into number of moles. Whatever is the given quantity, convert the given quantity into number of moles, right? So first of all, I am given with the mass of KClO3. Have a look. I am given with the mass of KClO3. Mass of KClO3 is given to me. Correct? This is something which is given to me. This is the given quantity. I am given with the mass of KClO3. If I am given with the mass of KClO3, what am I supposed to calculate? I am supposed to calculate the moles of KClO3 first, which is going to be equal to mass of KClO3 divided by molar mass of KClO3 when you calculate, which is 122.5. The value comes out to be 0.1. I got 0.1 moles of KClO3. As I told you, whatever is going to be the given quantity, convert the given quantity into number of moles, yeah? Now have a look. I am given with the mass of KClO3. I'm supposed to calculate the mass of O2. I'm given with the mass of KClO3 as per the equation. I'm supposed to calculate the mass of O2. That means I've got nothing to do with this KCl. I've got nothing to do with this KCl, right? Now, just relate KClO3 with oxygen. Just relate their stoichiometry. I can say you are going to treat these stoichiometric coefficients as moles, as I told you a few minutes back, yeah? You guys are going to say something like this. 2 moles of KClO3, 2 moles of KClO3 gives 3 moles of oxygen. 2 moles of KClO3 gives 3 moles of oxygen, yeah? Can I say 1 mole of KClO3 should give me 3 divided by 2 moles of oxygen? Can I say something like this, yeah? Absolutely. If 2 moles of KClO3 are giving 3 moles of oxygen, can I say 1 mole of KClO3 should give 3 by 2 moles of oxygen? But do I have only 1 mole of KClO3? No way. We have got 0.1 moles of KClO3. Right? If 1 mole of KClO3 gives 3 by 2 moles of oxygen, can I say 0.1 moles of KClO3 gives 3 by 2 multiplied by 0.1 moles of oxygen, and this value will come out to be 0.15. Right? So you got to know exactly the number of moles of oxygen which are getting liberated, which is 0.15. These many moles of oxygen are getting liberated. But am I supposed to calculate moles of oxygen liberated or mass of oxygen liberated? I need to calculate mass of oxygen liberated. What did I calculate? I calculated the moles of oxygen liberated, right? I was supposed to calculate mass of oxygen liberated. So mass of oxygen liberated. Do you remember how do we convert moles into mass? In the last session we saw. We just multiply moles with the molar mass of the substance. So mass of oxygen is going to be equal to number of moles of oxygen multiplied by molar mass of oxygen. As simple as that. Number of moles of oxygen 0.15. Molar mass of oxygen is 32. The value comes out to be 4.8 grams. So you got to know exactly 4.8 grams of oxygen are being liberated when 12.25 grams of KClO3 will be heated, right? Let me know first in the chats if it is clear to everyone. Okay? Let me know first. Is it clear? Is that clear? Right, people? Just let me know fast in the chats if it is clear. See, this question we solved by means of mole method, right? We can solve the same question by means of mass method as well, right? We can solve the same question by means of mass method as well. See, how do we solve the same question by means of mass method? Have a look exactly. See guys, you saw exactly how to use the mole method. Now use the mass method. Simple it is. See. In the mass method again, what do? You need to balance the reaction, and the reaction is already balanced, right? Now, if I ask you, what is the molar mass of KClO3? You'll say molar mass of KClO3 is 122.5 grams, right? Yes? Okay. Molar mass of KClO3, if I ask you, what is that going to be? 122.5 grams. Mr. NEET aspirant, you can go to some other channel, bro. I'm continuously watching you. Okay, you can go to some other channel, not here. Yeah? I think you have something difficulty in understanding the English. I think so. You can go to some other channel, not here. Okay, this is KClO3, right? What is the molar mass of KClO3? Molar mass of KClO3 is simple, that is 122.5 grams. What does that mean? That means mass of 1 mole of KClO3 is 122.5 grams. Do I have only 1 mole of KClO3 or 2 moles of KClO3? We have 2 moles of KClO3, right? Mass of 1 mole of KClO3, that means molar mass of KClO3, that is 122.5. But I have 2 moles of KClO3. 2 moles of KClO3 will have the mass of 122.5 multiplied by 2. The value comes out to be 245 grams. Right? So 245 grams is the mass of 2 moles of KClO3. Yeah? If I ask you, what is the molar mass of oxygen? You will say molar mass of oxygen is 32 grams. Correct? Molar mass of oxygen is 32 grams. That means mass of 1 mole of oxygen is 32 grams. Do I have 1 mole or 3 moles? I have 3 moles. If the mass of 1 mole of oxygen is 32 grams, what is going to be the mass of 3 moles of oxygen? 32 multiplied by 3, that means 96 grams. Right? Can I say something like this? Can I say 245 grams of KClO3 gives 96 grams of oxygen? Yes. Can I say 1 gram of KClO3 gives 96 divided by 245 grams of oxygen? Right? Absolutely. 245 grams of KClO3 are giving me 96 grams of oxygen. So 1 gram of KClO3 gives me 96 divided by 245 grams of oxygen. Do I have only 1 gram of KClO3? No. We have got some 12.25 grams of KClO3. If 1 gram of KClO3 is giving me these many grams of oxygen, can I say 12.25 grams of KClO3 are going to give me 96 divided by 245 multiplied by 12.25 grams of oxygen, and when you solve this term, it will again come out to be 4.8 grams. So finally, 4.8 grams of oxygen are being liberated over here, right? Is it simple? Is it simple, my dear elites? Earlier one was the mole method, now this is the mass method. As simple as that, yeah? In the earlier method, I was relating the moles. Now over here, I'm relating the mass. That's all. That's all. Rest, everything is same. And it's going to be entirely your wish to select the procedure and solve it, yeah? Perfect? Okay, so let's move on to one more question. This is going to be the last question which we are going to solve in the tonight's session. Rest will be doing in the next session, right? Because it's already 9:30. I've got one more session coming up on JE channel, right? Okay. See guys, the question says, calculate the volume of oxygen. Calculate the volume of oxygen produced at STP by complete combustion of 570 grams of octane, right? By 570 grams of octane. First of all, before solving this question, let me tell you one simple thing. Whenever you'll be having a general hydrocarbon CXHY, right? Whenever you'll be doing its combustion, you are going to make this hydrocarbon to react with oxygen. It will be always leading to the formation of carbon dioxide gas, and with this you're going to get H2 as well, right? Whenever you will take a hydrocarbon, general hydrocarbon CXHY, whenever you'll make it to react with oxygen, right, with the excess of oxygen, you'll be always getting carbon dioxide and water as the product. Point number one. Point number two, how do we balance this combustion reaction? There is a general method of balancing this combustion reaction. And how it's going to be? How many carbon atoms do we have over here? X. So this X, I'm going to write the stoichiometry coefficient over here. What is the stoichiometry coefficient? I mean, how many hydrogen atoms do we have over here? Y. So this Y divided by 2, I'm going to write over here. And the stoichiometry coefficient of oxygen, I'll be always writing X plus Y by 4. This is the way by means of which we balance the combustion reaction. Okay. For example, I've got the hydrocarbon CH4. So what is the value of X? That's 1. What is the value of Y? That is 4. The value of X is 1. The value of Y is 4. Correct? I'm making it to react with oxygen. It will first of all lead to the formation of carbon dioxide, and with this you'll be writing water. Correct? What is the value of X? It is 1. So just write 1 over here. What is the value of Y over here? It's 4. Just write 4 by 2. 4 by 2 means 2. Right? And this is going to be X plus Y by 4. So 1 plus 4 by 4. 1 plus 4 by 4. 1 plus 4 by 4 comes out to be 2. The reaction is automatically balanced. I hope you got to know how to balance it. Now, let's try to solve the question. Calculate the volume of carbon dioxide gas produced at STP by complete combustion of 570 grams of octane, right? We have got octane. Octane means C8H18. This octane. I'm doing the combustion of octane. That means I'm going to make it to react with the oxygen. It's going to liberate carbon dioxide, and with this, you're going to get water as well. This is the reaction which is going to happen, right? This is the reaction which is going to happen over here. Absolutely, this is the reaction, yeah? Now, first thing, you have got a lot of methods to solve this. Well, I'll be using simple mole method, and let's try to solve it, yeah? I'll be simply using the mole method, and let's kill the equation. First of all, I'll try to balance the reaction, right? That's something which we do all the time. What is the value of X? That's 8. Put this 8 over here. What is the value of Y? That is 18. So 18 divided by 2, that comes out to be 9. 9 over here, right? So this is going to be X plus Y by 4. Stoichiometry coefficient of O2 is going to be x plus y divided by 4. When you solve this, the value comes out to be 25 by 2. This is the stoichiometric coefficient of oxygen. Now you need not to check it. The reaction would have got automatically balanced, right? You need not to check it again. The reaction will be automatically balanced. Point number 1. Point number 2. We are given with what? We are given with the mass of octane. We are given with the mass of octane. We are supposed to calculate the volume of carbon dioxide. We are given with mass of octane and we are supposed to calculate volume of carbon dioxide, right? That means I've got nothing to do with this oxygen. I've got nothing to do with this water, right? Okay. If I'm using the mole method, what am I supposed to do? If I'm using the mole method, what am I supposed to do? If I'm using the mole method, what am I supposed to do? I'm supposed to convert the given quantity into number of moles. I'm supposed to convert the given quantity into number of moles, right? The given quantity is 570 grams of octane. So I'll be calculating the number of moles of octane, which is equal to mass of octane, which is 570 grams, divided by molar mass of octane. When you calculate it 114, the value comes out to be 5. The value comes out to be 5, right? So these many moles of octane we have. I converted the given quantity into number of moles. I convert the given quantity into number of moles, right? Now, use the simple mole method. Stoichiometric coefficient over here is 1. Stoichiometric coefficient over here is 8. Can I say 1 mole of octane? Can I say 1 mole of octane gives 8 moles of carbon dioxide? 1 mole of octane gives 8 moles of carbon dioxide. Do I have only 1 mole of octane? No, I have got some 5 moles of octane. If 1 mole of octane is giving 8 moles of carbon dioxide, can I say 5 moles of octane are going to give me 8 multiplied by 5? The value comes out to be 40 moles of octane. Sorry, 40 moles of carbon dioxide. So basically, I got to know the number of moles of carbon dioxide which are being liberated. And how many moles of carbon dioxide are being liberated? 40. Was I supposed to calculate the moles of carbon dioxide liberated? Was I supposed to calculate the moles of carbon dioxide liberated? I was supposed to calculate the volume of carbon dioxide liberated. People, do you remember how do we convert moles into volume at STP? Yes, we multiply moles with 22.4, that's all. So volume of carbon dioxide liberated at STP is equal to moles of carbon dioxide liberated multiplied by 22.4. The value comes out to be 896 liters. So 896 liters of carbon dioxide would have got liberated at the end. Yes? I'm sure it is clear to everyone. Perfecto? Okay. So people, one question I'm giving you as the homework. And this is the question which you guys are going to let me know, right? Of course, Mohan, content will be same everywhere. Of course. Yeah? Because the syllabus does not change. Yeah? When the syllabus will change, then we will change the content as well. Correct? Perfect, guys. So this is something which you guys are going to do on your own. Okay? The rest of the things, the rest of the questions, I've just started the stoichiometry. Right? The stoichiometry is not complete. This was just 5 to 6% of stoichiometry. Rest of the stoichiometry, we are going to continue in the next session. Yeah? Perfect? So let's end the session right here. Do not forget to like the video, share the video with your friends, and do not forget to subscribe to the channel as well. And do write the answer of this question in the comment section, okay? Perfect. And wherever you'll be having any sort of doubt or whatever you'll be having, do let me know every single thing in the comment section, right? Perfect. Okay, then take care. God bless you all. Love you all.